think that it's indisputable that the genetic information interacts with virtually every, well, not virtually every, with every system of the body. It probably does play some role in health and disease across the entire spectrum.
Precision medicine assumes that at some point we will have much more precise information to precisely diagnose individuals, and then that will allow rules-based treatments to be applied.
For the first time, personalized medicine will allow us to precisely target individual risk and precisely target the approaches to mitigating that risk and affecting better treatments.
But I think it's also important to recognize that precision medicine is not equivalent to genomic medicine. Genomic information is going to be part of the precise information that is needed.
And that includes also relatively common conditions like breast and ovarian cancer and colon cancer, where I think very large numbers of people have benefited.
The remarkable thing about cancer is it's a genetic disease that's mostly about the changes in genes from the normal cells being born with normal genes to cancer cells having abnormal genes.
We call it real-time sequencing for some cancer patients, where we've had patients who are in the clinic, their diagnosis is a little ambiguous. We've been able to apply whole genome, exome, transcriptome sequencing to those individual cases, and we've been able to find clues that allowed them to be treated with a drug that they wouldn't have gotten, right, in any standard therapy, and that's actually saved some lives.
In my view, this is going to be transformative because I think we are going to be moving away within the next 5 to 10 years from a disease that has been primarily defined by histology and pathology and site of origin to a disease that will be characterized by the molecular drivers.
We're seeing this start to happen with cancer treatment in many very different ways. So for example, there are glioblastomas that have mutations in the PDGFRA gene, and there also are gastrointestinal stromal cell tumors. These are the same gene in very different tumors, may be susceptible to the same types of therapies.
We've been able to make discoveries that can now guide not only dosing, but the potential for adverse effects. I think in cancer, genome sequencing is going to be extraordinarily important.
New genome mutations in cancer have been leading to new treatments, and we can expect that this process will continue and develop over the next years and will make a real difference for cancer patients.
I think we always knew that it was going to be a really complicated problem to take the genome once we had the sequence finished and start to apply it.
The truth is that actually some things came down the pike very quickly and were translated into clinical care. Other things take a longer time, partly because we only have the very beginning of an understanding of how these genetic factors influence health and disease.
I think the technology should push to the point where it becomes very commonplace and pretty much as simple as a basic hospital test.
Really the goal, of all of the tests that we offer is a better ability to understand the basis of disease in patients and therefore enable them to get better access to treatment and ways to, prevent ongoing disease.
There have already been some major successes in terms of implementation, so we're not talking about something that's going to take generations to see the light of day.
So I want my iPhone in 10 years to be an iSeq. I want to be able to plug a little connector in, put a drop of blood on that, and in an hour or so, hit the cloud, get all the answers out of the knowledge base that we build through big projects like TCGA and the Microbiome Project, etc. And basically get an interpretation, right? We wanted to say, here's the diagnosis.
I think pharmacogenetics is likely to be, well, perhaps next in line, although I don't know how visible that will be, because my prediction is that a lot of that's going to happen behind the scenes, that it will be in the electronic health record and the prescription tools that people use, And so testing will have been done. Patients may or may not fully realize that they were tested. Their doctors may or may not even realize that they were tested. But the systems will say, this is what you should do now in terms of dosing a particular medication or even choosing one based on that individual's pharmacogenetic profile. And I think that's the way it ought to be.
We can't overpromise genomic medicine in places where there is no established utility of that information. We have to be careful about really only making claims where claims are due, where there is a beneficial impact of using a genetic test, and in those cases, they should be used.